Hello guys, how are you? What are you doing? Today we will starting our lecture number 6. So this video is incoming of Herodo series. Okay, this is the lecture number 2 of mathematics problem. Today we will start problem number 8. In first video lecture we have already done problem number 1 to 7 solution. Okay, so guys, this is the very beautiful problems. Okay, these are very beautiful problems. If you want to develop your understanding into physics subject, okay, or especially for j advanced students, so they can purchase my courses, or if NEET students they want to improve their rank, so they can also, I suggest you, they can also purchase. Okay, but before attempting this series, I suggest you first go through my lectures, then after attempt yourself these problems. Otherwise, this will not be helpful for you. First attempt. When you attempt 2 3 times, then come. So now guys, for to purchase this series, you can visit our website www.valueedupoint.com. Okay guys, to purchase this series, you can go through my our website, or you can download our app. Both of ways you can download, you can purchase this course. Is it okay, guys? Now we are starting problem number 8. Okay, without delay, we are starting problem number 8. So, what is question saying, guys? Here, two boats. Look at this. First, read question 2 3 times. Two boats and B move away from a bay anchored at the middle of a river along the mutually perpendicular straight lines. Okay, so what is happening? A river, or in between the river, a bay. Okay, so this is used for information, to get the information of shifts. Okay, so now the next question is saying boat A along the river and boat B across the river. Okay, so having moved off an equal distance from the bay, the boats returned. To find the ratio of motions of boats to and to b, ratio of times of motions. If the velocity of each boat with respect to the water, that is equals to eta 1.2 times greater than the stream velocity. So what is saying, first of all, we note down this last line. Okay, the each velocity. Okay, so assume that the velocity of stream velocity, okay, the river velocity or stream velocity, the river velocity, that is equals to v naught, and the boat velocity. Okay guys, the sorry, the boat velocity, okay, with respect to water, that is equals to eta times greater than the stream velocity, or we are assuming the boat velocity, that is v dash. Okay, so we have a relation, that is v dash upon v naught, that is eta times. Okay, remember this relation, or we can say equation number first. Now what is happening, guys? Look at this very carefully. Okay, what is happening here? Then we will try to solve. First, understand the question. What question is saying? Okay, so assume this is the river, guys. Okay, this is the river. Right or wrong? This is the river, guys. Okay, or in someone middle here. Okay, guys, here in between middle. Okay, one by is, okay. This is the boy. It is anchored here. So now what is happening? One boat, okay, the boat A is going this side. Is it okay, guys? And again returning to the bay. Sorry guys. Again returning from this point, and the distance that it traveled, that is L, L distance going and coming, again L distance. And the boat B, it is going in this direction. Okay, boat B is going perpendicular direction. Okay, and he moves L direction, and again he comes towards the boy. And so this is again L length. Okay, so this is the boat A. This is the boat B. Is it okay, guys? Now, to solve these problems, we will see some basic concept of kinematics. So, for boat A, the downstream velocity will be, guys, when boat that will be v dash upon v naught, and the upstream velocity, when this will go, a boat A will go in this direction, then the flow velocity of river. Okay, the flow velocity. This is the flow velocity of river. It will add, or it will increase the speed of boat, and while upstream is when returning the speed will be decrease, and that will be v dash upon v dash minus v naught. Is it okay, guys? So for boat A, downstream velocity this, upstream velocity this. Now in case of boat B, okay guys, now in case of boat B, you can clearly see that, okay, to remain in this direction, okay, to remain in this direction, boat B has to start, have to go in this direction. Okay, and the velocity, flow velocity will be in this direction, and the net velocity will be in this direction. Okay, this is the net velocity. Is it okay, guys? This is the v dash, or this is the v naught. So this net velocity will be v dash square upon v naught square from Pythagoras theorem. Okay, so this velocity will be same while going this side by B, or while returning towards the by. This velocity will be same in case of B boat. Okay, guys. Now he is asking the ratio of TA upon TB, the time taken by boat A and the time taken by boat B. So to cover the distance, the time taken by A, that will be we know the time is length upon, or distance, yeah, displacement upon velocity. So first is going downward direction, downstream side. So this velocity will be v dash plus v naught. Or while returning, the upstream velocity will come. So this is the time taken by A. But in case of B, the, okay, the length is L and the velocity will be v under root v dash square minus v naught square. Again, while returning, the velocity will be same. Is it okay, guys? Up to here? Okay. So we solve this TA upon. Now what we have to do? I am taking L is here common. Okay, or C here, A plus B, A minus B. So this will comes out to be v dash square minus v naught square. And you further solve it here, v dash minus v naught, or here v dash plus v naught. Is it okay, guys? And bottom side, this will comes out with twice L upon under root V dash upon V naught square. This is L, guys. So here L is L, cancel out. Here guys, look at this. Here V minus V dash plus V naught. Sorry, minus V naught plus V naught cancel out. Or here, this is the guys. This term is the square of this. Okay, so we can write down. So this will become into root. So what is the expression? Next expression, Ta upon Tb, that will comes out to be here 2v dash. Okay, here 2v dash upon under root v dash square minus v naught square. Again, this 2 is remaining here. Here 2 is to cancel out. So is it okay, guys? So now I am taking v naught square here is common. Okay, v naught square common from here, and I am writing this v naught here v dash upon v naught. Okay, guys, and here you can see v dash upon v naught square is equals to minus 1. This is the Ta upon T. Now look at this problem, guys. Here we know the v dash upon v naught, that is equals to eta. Okay, guys, that is equals to eta. We know. Okay, so now we put the eta here, and we know the value eta is 1.2. Okay, guys. So Ta upon Tb will comes out to be eta upon eta square minus 1, and we know the value of eta, that is 1.2 upon 1.2 square minus 1. Okay, when you solve this, okay guys, don't confuse, this is the minus 1. Okay, Ta upon Tb. When you solve this expression, this guys will comes out to be approx 1.8 times. Okay, guys, so this is very important expression. This is very good problem. Okay, easy if you know the concept, so easy, but if you don't know the concept, so that is good problem. Okay, now we are going to for next problem. Okay, guys, we are going to next problem, that is 1.9. Here one boat moves relative to the water with a velocity that is eta 2 times less than the river flow velocity. We know the river flow velocity, that is v naught, and the boat velocity v dash. So what is saying, v dash is equals to v naught upon eta dash. So look at this, guys. This time the velocity of boat is less than river velocity. Okay, or generally in case boat velocity is more than the river velocity, but now in this case the river velocity is more. Okay, and the value of eta, that is given 2. So is it okay, guys? V dash upon v naught. So we find out the first expression from this line. A boat moves with the relative to the water with a velocity v dash, which equals to eta 2 times less than the river flow velocity. Is it okay, guys? Now at what angle to the stream direction must the boat move to minimizing drift? So what is happening, guys? What question is saying? Okay, this is the river. Okay, is it okay, guys? Oh, this is the river flow velocity. River in flow in this direction. That is v naught. What is happening? Okay, suppose that this is the width of the river, and this is the point A, and this is the point B. Now one guy wants to cross this river and reach the this point, but because the flow velocity is more, so he will not reach here, he will reach here. Okay, so this distance is termed as drift. Okay, this distance, that distance, okay, from B point to here, that is termed as drift. Okay, that is termed as drift. So this drift will be minimized if swimmer start to swim in this direction, guys. Otherwise, see, look at this. Look at this. If swimmer in this direction, then drift will be more because the velocity v naught, and that this v again it will go here, reach here, reach here, reach here, reach here. So only in this case, he will, or here the flow velocity is more. That's why he will not reach here. He will flow. So drift here, drift will not be zero in this case. Why? Because the v naught is more. So what we will do, in this case, the drift will be minimum. So for minimum drift, so swimmer start to swim in this direction, and the velocity will be v dash. So are you getting my point? Are you getting my point, guys? And the we know the river flow velocity, that is v naught. Okay, the river flow velocity, that is v naught. Okay, this is the river flow velocity. Hence, the net resultant velocity will be in this direction. Okay, in this direction, and that will not be in previous case under root square. This will be different. Okay, we have to calculate. So this is the v net. So or he is making or now we have to find out the angle. What angle he is start? So that angle is theta, and the theta is angle from the flow velocity. Is it okay, guys? Theta is angle from the flow velocity. That flow velocity v naught, and this the v dash. The v dash speed of boat. Remember, speed of boat with respect to water. Is it okay, guys? Now, whenever you see this minimize or maximize, so you have to make relation between these two quantities. Okay, so we have to minimize drift. So that drift I termed as x. Okay, that drift I termed as x. We have to make relation between x and theta, some relation. Or sorry, or not is proportional. We have to calculate x in terms of theta, and for minimizing or maximizing, we will take first derivative dx upon d theta, and we make it 0. Okay, so this will give either maximize or either minimize. When we take double derivative, if it is less than 0, then this will be maximize, or if it is greater than 0, this will be minimize. Is it okay, guys? So now first we will make relation, and then we'll take differentiation. So now how can we derive this x? So look at this, guys. We know x is the distance, and we know the time taken. These guys will time take from reach from point to cross the river. The boat will take the time cross the river t. Okay, and the time taken by this drift, that is also t. Is it okay, guys? Is it okay? Now, guys, the uh, time taken to cross this river. Okay, the width of the river, that is d. Okay, width of the river. So the time taken to cross the river. Okay, suppose that this is the time t. That will be t, the distance upon velocity, and the velocity of this boat will be perpendicular velocity. Okay, in our direction. So if I take this the theta, if I take two components of this v dash, the one will be v cos theta and the another one v sin theta. So v cos theta, the perpendicular component of this this will be v dash cos theta, v dash sin theta. Okay, so this is the time. So same time also will take this boat for this drift. Okay, guys. Sometime we'll take this also this drift. Okay. So now again we write down. Okay. Now again we can write down v dash. We can write down the x in horizontal direction. The drift, the time taken will be same. Now the velocity of boat in x direction, that is v dash cos theta, and plus the flow velocity. Okay, the flow velocity will add, that is v naught, and that into this velocity into time. Now time we have already calculated, because to cross the river and to reach the to cross the river in y direction, when you move in a y direction and x direction, the time will be same in this direction while going, or to reach that point in this direction, the time will be same, that is d upon v net. That will be, guys, d v dash cos theta plus, or v naught we can write down eta dot v dash, or time is d upon v dash sin theta. Okay, guys, we can further solve it. X is equals to d, guys, v dash we take common, so d outside, so inside that will be cot theta plus eta cosec theta. Is it okay, guys? Now you can clear see the x already, x has come in terms of f of theta. Now what we have to do, you have to do, now what you have to do, you have to differentiate dx by d theta. Okay, so this is constant, and we take the cot theta, the differentiation of this, that will be uh, cosec square theta, and the differentiation of, again this is the constant, and the differentiation of this will be cosec theta into cot theta. When you put this value, if I take, okay, when you put this value 0 and I take minus cosec theta common, then inside that is cosec theta plus eta times cot theta. So guys, this cannot be 0. Why? When you write down 1 upon sin theta, if you theta put 0, then this will value become infinite. Okay. So if you put infinite here in spite of sin theta, then it will give 0. And to put infinite, is it not possible? So this, the 0 does not come in its range. Now again we solve, further solve is, that will 1 upon sin theta and eta times cos theta upon sin theta. Again if I take 1 upon sin theta and 1 plus eta times cos theta, so again this will not 0, so this will be 0. So we can say cos theta is equals to minus 1 upon eta times. Is it okay, guys? And cos theta is equals to minus eta times, we already know, that is 2. So theta will be, okay, this is minus half, so theta will be 120 degree. Okay, or we can say pi minus pi by 3. Okay, or 2 pi by 3. Okay, or 2 pi by 3. So the boat start to swim at an angle 2 pi by 3, then drift will be minimum. Or we can find out the drift also when you put this 2 pi by 3 in this expression. So you can also calculate the minimum drift, guys. Is it okay, guys? Is it okay? So now we are starting the next problem. That is problem number 110. Now two bodies were thrown simultaneously from the same point. That is one step. So what is happening, guys? See, look at this. So whenever you see these type of problems, always use velocity of approach. Okay, or relative velocity concept. Okay. So one two bodies were thrown. Okay. One body is drawn in this direction. Okay. In this direction, one body is thrown. Let us say this is the body A. And another body is thrown at an angle. The velocity is same V naught. The velocity is same V naught. At angle 60 degree. Is it okay, guys? So whenever you see, so what question is saying, one is straight up and other is at angle 60 degree to the horizontal. Is it okay, guys? Now the initial velocity of each body is equals to V naught, that is 25 per second. Okay, the initial V naught and the V naught is the its initial velocity. Neglecting the air drag, find the distance between the bodies where t is equals to 1.6 second. So guys, whenever you see these type of problems, always use this relation. We know the displacement. Okay, the displacement we know that is u t plus half at square. This is the equation number second equation of kinematics. So as the displacement is change in position. Okay, so we convert this expression into relative motion. Okay, so the change is position r delta r12, or this is initial velocity. Okay, we can write down 12 into time plus half a12, okay, into time t square, or we can write down this r12 r final minus r initial. So r initial 12, okay, plus u initial 12 time taken plus half. So when you use this expression, so this problem will be very easy. So the initial difference, the initial position difference 1 2, because they are thrown same point. Okay, this is origin, so this value is 0, and we know the acceleration in both the case, that is acceleration g constant. Okay, so the relative acceleration also 0, so only this terms is left. Okay, so r12, if you take modulus of this, so you will find u the initial velocity, initial relative velocity, okay, into time is given 1.7 second. So we have to calculate only this part, guys, and we know the initial relative velocity, so that v12 we have to calculate. So this v12 v1 minus v2, and the magnitude of this in subtraction of vectors, you can easily calculate this v1 square plus v2 square minus 2 v1 v2 cos theta. Theta is the angle between these twos. Okay, guys, theta is the angle between these two vectors. So now we can easily calculate. Now we can easily calculate, guys. We can easily calculate, that is v naught. So here u naught, u initial 1 2, the magnitude will be here. The velocity is same. Okay, that is v naught square plus v naught square minus 2 v naught v naught. Now the theta is the angle between these two vectors. Now guys, this is the initial velocity vector, and the theta between that will be 30 degree. Okay, because this is the whole 90, so this will be 30. So we will put here cos 30. I think, is it okay, guys? Is it okay? So that will comes out to be, if I take V naught square is common, okay, so this will comes to be 1 plus 1 2, that will be, and that will be 2 minus root 3 by 2. Okay, and this expression under root V minus 2 minus root 3. Okay guys, or but we have to find out the relative distance after. So now guys, this value comes out to be V naught, we already know 25 meter per second, and the value inside 2 minus root 3. Okay, and the time that is equals to, already given, 1.70 second. Okay, 1.70 second. Okay guys, and that value comes out to be approx 22 meter. There is a separation or relative distance. Is it okay guys? So now as we are starting our next problem, that is 1.1. So look at this guys, what is in this problem, what is question is saying. Okay, two particles moving in a uniformly gravitational field and acceleration c. Okay, at initial moment the particles were located at a one point and moved with velocity v1 3 meter per second and v2 4 meter per second horizontally in opposite direction. Find the distance between particles at the moment when their velocity vector becomes mutually perpendicular. So what is happening guys, look at this diagram very carefully. Okay, suppose that this is the point O, this is the point O. Okay, here two particles, suppose that this is the particles A or first particle. Okay, its velocity is 3 meter per second, that is v1, which is equals to 3 meter per second. Is it okay guys? And for the another particle, suppose that v2, that is velocity v2, that is 4 meter per second. So initially they are horizontally thrown or in opposite direction. So what happen in this parabolic motion? They will, okay, they will be in motion. So suppose that at time t, okay, at time t the velocity vector, after time t the velocity vector becomes perpendicular. Okay, see guys. Okay, okay guys. So the velocity vector, okay guys, the velocity vector becomes perpendicular, means 90 degree. Is it okay guys? After time t. Okay, after time t the velocity of v2, that is v2 dash, and the velocity of v1, that is v1 dash. Okay. So now we have to find out this distance, that is r12. Okay, sorry, that is r12. Is it okay guys? R12. We have to find out this distance. Okay. So again we are using same concept. Okay guys. What is, we are already earlier in last question we have already discussed, that is the r12 will comes out to be v naught 12, their initial velocity into time. Okay, so now their initial velocity in opposite direction. Okay, so their magnitude directly we can calculate. Okay, guys, that is v1 square plus v2 square minus 2 v1 v2 cos pi. Okay, when you solve this, this will comes out to be v1 minus v1 plus v2. Okay, here cos pi is equals to minus. Okay, so we can directly write down this. This is v1 plus v2 into time t. Now, guys, we have to calculate this time. Okay, so how we will calculate this time? In this way, guys. Look at this. Suppose that after v1 dash is the velocity after time t. Okay, after time t v1 dash, after time the velocity of after particle 2, that is v2 dash. Okay, so that will be perpendicular after time t, and that time will be that time where the velocities are perpendicular. So at that point their velocity vector will be, their dot product will be 0. So we can, this is final velocity, so we can use first equation of kinematics, that is q plus at. Okay, so here initial velocity v1, so v1 plus this acceleration, that is equals to g into t. Okay, guys, again v2 plus g into t, that is equals to 0. Is it okay, guys? Now what we have to do, when you solve further, okay, when you solve this further, so this multiply this, okay, v1 dot v2 plus, look at this, guys, v1 dot z into t plus, again we will multiply zt dot v2 plus, again we multiply gt dot gt. So now, guys, look at this. This at initial point. Look at this guy diagram. At initial point, okay, here this is initial point, and the initial point, the acceleration is downward. Okay, guys. So the angle between these two, that is 90. So when two vectors are at 90 degree, their dot product will be 0. Is it okay, guys? So this portion will be 0. This portion will be 0. Is it okay, guys? Now again, dot product of these two vectors. Initially they are at 180 degree. Okay, so this will comes out to be v1 v2 cos theta. Theta is equals to pi. So this will come simply v1 upon v2. v1 into v2 plus, this will become, when two same vector are dot product, are in dot product, so it will simply will comes out to be the square of their its modulus. So it will comes out to be g square t square, that is equals to 0. So here you can calculate t is equals, t square equals to v1 upon v2 or g square. Is it okay, guys? So time will already we have found under root v1 upon v2 and upon g. This is the time. Okay, guys. Now the relative velocity r12 is equals to r12 is equals to v1 plus v2 under root v1 into v2 upon g. Is it okay, guys? Is it okay? So again, this is the important problem, or if you know, okay, the very good problem, guys. So now, guys, we are starting problem number 1.12. Here you can see 3 points, okay, are located at the vertices of equilateral triangle. which sides equals to A. They are all stars moving simultaneously with velocity u, constant in modulus. Okay, but direction is different. With first point heading continuously for the second, second is heading third, third is heading for the first. How soon where they will points? Okay, sir. Okay, guys, look at this. What is happening here? Okay, what is happening here? Look at this. This is the equilateral triangle. Okay, this is the equilateral triangle. So what is happening here, guys? Here is particle A. Here is particle B. Here is particle C. So A is coming towards B. Okay, A is coming towards B. Okay, simply B is coming approaching towards C, and their velocity is same. And C is approaching towards A. Its velocity also same. So what is happening, guys? Okay, because they are going same velocity, that's why they will not meet. That's why they will not meet any point. Okay, that's why they will not meet anywhere on this triangle. So next, what will happen? Again, okay. Next, what will happen, guys? Again, this particle will A, B, and C. Again, okay. Again, third triangle. Okay. Again, fourth triangle. In such way, this scenario will go, and at the point of this centroid, they will meet. So, guys, what is going here? You understand? You got the point. Very important concept. They will not meet anywhere in on triangle. They will meet on the centroid. They will go in this direction. Okay, and at the finally they will meet here centroid. First of all, you remember this concept. Now we know the edge of this equilateral triangle, that is A. So we take any arbitrary triangle. Okay, we take any arbitrary triangle. So we take any arbitrary triangle to find out this question answer. So what is happening here, you know, guys? So look at this. So assume this distance is L, any arbitrary triangle. Okay. So here A is coming towards this side. Okay. We are taking for two. We are taking for only 2 points. Is it okay, guys? Is it okay? And for B is in this direction. That is V. This is the A. This is the B. The velocity is V, and the velocity is this. Okay. So when you extend this arrow, okay, when you extend this will make, okay, this will make, okay, or we can say this A will make, this will make here, this is the angle 60 degree, this is the angle 120 degree. Okay, or we can say 2 pi by 3. Is it okay, guys? Okay, this is the length L. So earlier we studied the velocity of approach. Okay. Uh, Earlier we studied their relative velocity unit vector is equals to their velocity of approach. Okay. So this concept should be in your mind, guys. Okay. Okay. So what is the distance of separation distance? Yeah, approaching distance, that is L. Okay, or it will decreasing, so dl by dt. And the relative velocity, okay, and the relative velocity will be, we use the concept of relative approaching velocity of approach. Okay, so this is velocity v. So what we will do, guys, we take we will take the velocity of v in the direction of a. Okay, and that will be, suppose that this is the velocity of v, we will take in the direction of a. Okay, and okay, guys, in the direction of a. And do you know the magnitude of this vector? The magnitude of this vector, suppose that this 2 pi by 3 is equals to alpha angle. So this will be v cos alpha. Okay, guys. So the relative velocity will be v minus the approaching velocity, that will be v, or we will take okay, the approaching, that will be v12. Okay, v12. So v1 minus v2, and v2 is in this direction velocity, that is v cos alpha. So this is very important result, guys. You have to learn. This is very important. Now what we have to do, uh, we have already know the cos alpha, that is cos 2 pi by 3, and that value will be minus cos 61 by 2, that will be minus 1 by 2. Is it okay, guys? So here dl by dt is equals to v plus v by 2, or that will be 3v by 2. Okay, guys, so we will integrate dl over here 3v by 2 dt. So time 0 to t, when they meet at uh, uh, centroid or collide, or here the initial distance a, or they are going to, distance will be 0. So that will comes out to be a, and when you solve this, this will 3v by 2 into time. So that time will comes out to be 2a upon 3b. So this is very good question, guys. Okay, so now what is the next question? So the point A moves uniformly with velocity v, so that v is continuously aimed at point B, which in its moves rectilinearly and uniformly with velocity u, which is less than v. At the initial moment of v is perpendicular to u, and the points are separated by a distance L. How much will the point converge? So what is happening here, guys? Look at this. This is the initial scenario. Okay, this is the initial scenario. This is the initial scenario. Okay, initially the well is point A. This is the point B. It's going in this direction, and this is the point A. It's going in this direction. Okay, this is the point A. The velocity of A, that is v, and the velocity of v, that is u. Okay, guys. Suppose that, and to suppose B starts, we come here. So Again the aimed at here, so A will come here, U will come here. So at so A, it will go in this direction and finally it will meet here. Okay, it will cross here. This point B. Okay, guys. So in this scenario, it will go. And the initial length is L. Their separation, initial separation length, that is L, and their velocity is initially perpendicular. Is it okay, guys? So now again we are taking the velocity of approach concept, dl by dt, and that will be equals to v minus u cos alpha. Is it okay, guys? Okay, we are taking this velocity at any point. Okay, at any point, suppose that at after time t. Okay, after time t, the v the point A is here or B is here. Okay, so the velocity of A along this line, okay, or B is here. Okay, so now this angle is alpha from the horizontal. So we take again, this is angle alpha, so this value is u. So we take the velocity of u in the direction of velocity of A. So that will be v minus u cos alpha. Again, this is very important, guys. We are facing difficulties to write down this equation, that it is then you can't solve this type of problems. So here we are using velocity of approach. Is it okay, guys? Now for any, so now suppose that this is the distance x. Okay, this is the distance x. Now the time taken, okay, to cover the distance x from A and B also, that will be same. Okay, the x direction, that will be same. So at any time t, okay, the at any time t, the covered distance in x direction, will be same for A and B. Is it okay, guys? Now for the particle B, that will be u and t. Is it okay, guys? Okay. When they reach here, the time taken will be u, and the velocity of v in horizontal direction, that will be v cos alpha. Okay, guys. So hello. So guys, that will be v cos alpha into dt. Is it okay, guys? Now, sorry, this is the not capital T. This is the small t time. Okay, and that small t, that will be delta x. Delta x is equals to delta x at any distance. Okay, this is the at time t. This is the at time t, the horizontal distance covered by A. Is it okay, guys? When you differentiate this, okay, so this horizontal distance, the maximum horizontal distance will be this. Okay, and suppose that the time taken to reach, that is capital T. Okay, so the distance we can, the velocity we know, the for particle B, that is u, and the time is t. Distance, velocity into time. And if we take v outside, that is constant, so cos alpha dt. So guys, using these two equation, okay, using first and second, okay, how can we correlate these two equations? See, guys, further we can write down dl is equals to V minus U cos alpha dt. So you can differentiate 0 to t. Here you can differentiate the initial difference, that is L, or here 0. So this will come here L. Again this will come V capital T, and this will come U cos alpha dt, 0 to t. So again we can, okay, we can replace this value, this guys, we can replace this integration value. Okay, that will comes out to be here, that will comes out to be U capital T upon V. Okay, so the time will comes out to be, when you take LCM and you further solve it, that is LV upon V square minus U square. Okay, so this is the answer of this problems, guys. Easy, but you have to, understand very deeply, otherwise it is very typical problems if you know, or but when you go through it once, so that will be easy, guys. Next time when you go through it, so that will be easy for you. Okay, guys, so we have completed, okay, 13 problems here. So you can download our okay website, sorry, you can download our app from Play Store, iStore. You can visit our website, you can purchase our courses, okay, or you can start your preparation JE and NEET and any other examination, bit set, okay, your ICR, okay, Olympiad, NTSE, KVPY, okay, we will cover all these examination, okay, or plus 11, 12th, NCRT, okay, CBSE, okay, any other state board, ICE, okay, ICE, and any national and state level boards we will cover in this portion. Or in next, in future we will also launch, after entering college, we will also launch different engineering courses, okay, for GATE or ES, engineering services, or any other engineering competition, is just like SSC, UPSC competition exam classes. Okay, we will soon, very soon, we will launch these courses also. But for you, you can start your preparation at very cheaper cost. Please, guys, again, I am telling you, no platform is providing at this lower, cheaper cost. Okay, guys. So thank you so much. Bye bye.